Hi, and welcome to my lesson on inequalities. And you can see lots of blank spots here. In fact, I have a download version of this where the student, you will have a copy of this and you will insert all the blank spots here. And along the way, learn hopefully some interesting things about inequalities. So, we'll begin with what is an inequality? Well, an inequality and whoops, let's get that Inequality. An inequality refers to one of the four symbols, and those four symbols are those alligator signs, like that, and that, and that. There are four of them in the inequality world. So this first one is known as greater than, and the other one is known as less than. And this other one that looks like greater than is greater than or equal to. See that extra little line right there? That's the difference. That's greater than, and then that's greater than or equal to. And the other one would be less than or equal to. Okay, now to go on here, a statement like this means x, or it could be any other number than, any number has to be or is greater than 4. And an example would be 5 or 6 or even 24. Anything as long as it is bigger than 4. And this could have an infinite number of solutions. So let's think about what that means, an infinite number of solutions, and even what is a solution? Well, we could very simply say, okay, here's an equation versus an inequality, and there's a lot of similarities, but there's also some differences. So in an equation, x is equal to -3. That would be an example of an equation. It has an equal sign, thus equation, and there is only one solution to this equation, and that solution is -3. Versus an inequality, everything looks the same, but this is x is less than -3, so there's many or an infinite number of solutions. So for this one here, x is equal to -3, I would say, yeah, there's one solution and it is right there. I'll put a dot there. But at x is less than -3, it looks a little different. And we would have something like this, where we would say, oh yeah, we have the numbers less than 3. Those are the solutions. So we're going to talk more about how to graph these inequalities and what they mean. Let's go below. So how to graph an inequality. Graphing statements like x is greater than 4 can be accomplished. And let me make my dot a little bit smaller. ACCOMPLISHED can be accomplished on a number line. So we're graphing the number is greater than 4, but not including 4. And I'm talking about this one right here. So for that reason, we then draw an open dot over the 4. So we draw an open dot over the 4, and I'm going to do that right now. Open dot over the 4. Then draw an arrow. Then draw an arrow in the direction. Sorry. Of the numbers greater than 4, which is to the right. So if we're talking about the numbers greater than 4, we just go, there's 4, and then the numbers greater than 4 are in that direction. Sometimes what I do is if I'm trying to graph this, and I'm thinking about, okay, the number's greater than 4. Well, what number would fit? Don't use 4, so don't use the actual number, but what number would fit? Like, I don't know, 5 is greater than 4, or 10 is greater than 4. And what direction are these numbers in? They're to the right. So you draw that arrow, and that's a graphical representation of, well, what's going on with the solutions here. So we'll go down to the next one, which is here, graphing x is less than or equal to -1. That one, first we have to read the statement. X is less than or equal to, -1. I better put a little negative right there. Yeah. So we have to place the correct dot over the 1. And I have this little guide right here on the right. If we have these inequality symbols, that would be an open dot. And if we have the extra line there, it would be a closed dot, which means it's equal to also, or could be. So think of a number other than 1, and that would make the statement true, say -4. So first, let me put that dot over the -1. Okay. Just remember, I'm trying to graph this statement right here. And then from there, we have to think of, well, what number would fit for -1? And we could say like -4. -4 is less than or equal to -1. So what direction is -4? It is this direction to the left. And that is my graph. Easy peasy. So now we have solving these inequalities. That's another thing. So we graph them. We identified what is an inequality. We graph the inequalities. Now we're going to be solving these one-step inequalities. And to solve a one-step inequality is similar to solving a one-step equation. It's all about inverse operations. So I have two examples here. Zoom in a little bit here, where we have a one-step equation and a one-step inequality. Look, x minus 4 equals greater than or equal to, and then the -2. So notice the only difference really is the inequality here and the equation here. And to solve this one-step equation, I'm going to add 4 to both sides. See, these are inverse operations. These right here, these are the inverse operations. If I see subtraction here, I'm going to use addition to solve it. But I have to do it on the same thing on both sides of the equal sign. And I did so. Right here, I added 4. -2 plus 4 is -2. I'm sorry, -2 plus 4 is +2. And there's my solution, 2. And that is to say 2 is the only number that will work. 2 minus 4 is -2. See? So in this one, I'm still adding 4 to both sides. Again, the inverse operations are playing right here. And instead of x is equal to 2, I have x is greater than or equal to 2 for my solution. So they work exactly the same way. We could have this one over here, where there is another pair of 1/8 an equation, and the same thing is set up as an inequality. And here's our equation, inequality. And notice here, this is division. Inverse operation means we have to multiply these two together. 2 times 6 is 12. So easy, because you can see 12 divided by 2 is equal to 6. So 12 is known as the solution. But here, hey, look, it's division. Same thing. 2 times 6 is 12. This x equals 12. X is less than or equal to 12. Same process, same answer. Or not same answer, but same type of answer. Where this is only 12, and this is not only is this 12, but also the numbers less than 12 will work. Okay, so notice the same process. The process is the same for solving equations. Let me get this. And inequalities. There is, however, one small difference. This is the part that gets students. When you have to multiply or divide by a negative number, negative in the second step when solving the inequality. Let me explain to you what that is. So right here, on this problem, I have, once again, I have division here. X divided by -2 is less than or equal to 6. And here, I have to see, since I'm dividing by -2, I have to multiply by -2. And this right here causes me to switch the direction of the inequality right there. So in my answer, that is the solution. And let's think about, okay, what is the solution to that? Any number greater than or equal to -12 will fit. Let's examine that. If I have x is divided by -2 is less than or equal to 6, and I'm picking a number greater than -12. Well, let's go easy. What's a number that's greater than -12? 0. 0 is greater than -12, so I'll put this in here, and I'll put in 0. Should this work? Well, 0 divided by -2 is 0, and 0 is less than 6. Check. Yeah, that is the solution. Any number any number larger than -12. Now, if we didn't switch this, then what we would have here, and let me erase this a little bit. Oh, I got my small eraser. Now, if I didn't switch it, that means I would have this as my solution, this right here. And that would be anything smaller than -12. Oh, God. Anything smaller than -12? That's not going to work. So I'm going to give you, see, and let me show you that it's not going to work. A number smaller than -12. Something smaller than -12 would be like -14. -14 divided by -2. Is that smaller than 6? Well, -14 divided by -2 is 7, and 7 is that less than 6? No. See, when I didn't switch it, I got something that was false, but when I did switch it, I got something that was true. That is the one tricky part about inequalities. Let's look at the other side here, and we have this. Okay, so you might be thinking, oh, if I just see a negative somewhere, that means I'm going to switch the inequality. But look here, I didn't switch the direction of the inequality anywhere here. And that is because when if this is divided by +2, I have to multiply by +2. So this is what I'm paying attention to right here. And I don't switch that. Okay, let's look at what's going on over here. Here's another case where we would have to switch it. Since I'm multiplying by -3 right here, that means I have to divide by -3 to solve. And since this is what matters right here. I'm dividing by -3, and I have to switch the direction of the inequality. See that? But if I look over here, this is another case where I don't switch. And let's look at the difference between the two. What we have here is I have -3x here, and I have 3x. But the 12 is negative. But that doesn't matter, because when I'm solving this, I'm dividing by a +3 right there. And I did not switch the inequality here, but I did switch this direction of the inequality here. Still have -4 here. But it matters all the difference, because here I'm talking about the numbers smaller than -4, and here I'm talking about the numbers greater than -4 would be a solution for the inequalities. And there you go. That is what you got to know about what are inequalities, graphing the inequalities, and solving the inequalities. Thanks for watching. Thank you for watching my tutorial video. I hope this has been helpful for you.